Hey everyone, my name is Puru and I welcome you all to this channel. Today we are looking at the problem find peak element. This is a medium level problem on Leetcode and it is a very nice problem that makes you think over your basic skills. Now let's look at this problem. A peak element is an element that is strictly greater than its neighbor. That means a ith element is a peak element if it is greater than I minus 1 as well as I plus 1. Given an integer array nums, find a peak element and return its index. If the array contains multiple peaks, then return the index of any of the peaks. Also, you may imagine that number minus 1 and numbers n is equal to minus infinity. That means any number that is out of the bound of our array is less than the elements that is at the first position and at the last position. Now the very easy approach that you can use is to take a simple loop, iterate over each element and check if it's greater than the previous element and the next element. So we can use a simple loop to find out the peak elements, but this approach will take the time of O of n. But we need to find a solution algorithm that will run in O of log n. So that is what this makes this problem challenging and interesting. Now mostly whenever we have to search an element and the complexity is log n, the very first thing that should strike our mind is binary search. Now in most of the cases you won't be given that this must be the complexity. So there's another method through which you should realize this question involves binary search. Now let's look at the example. Now the example is 1, 2, 3, 1. Now if we look closely, we have 1, 2, 3 and 1. Now 1, 2, 3 acts as a sorted array. And now the last element of the sorted array is obviously greater than the previous element because it's an sorted array. And as it is the last element of the sorted array, that means it will definitely be greater than the next element, because if that wouldn't be the case, then the next element would have been the last element of the sorted array. So that is why we need to implement binary search and we need to find the highest element or the last element of a sorted array. Now let's look at example number 2. Here we can see we have two sorted arrays. These. Now when we go through this, we will see that 6 is greater than 5 and 4, it's the last element. Also 2 is the last element of this sorted array and it is greater than both these numbers. Now how we will implement this binary search is, let's say the middle element for this array is 3. Now for 3, we'll check if 3 is smaller than the next element or not. Now 3 is smaller than the next element. That is true. That means we can shift our left head to this side, to the mid plus 1. Now as this is mid, our new left, so mid will be this element. Now this mid element is greater than our next element. That means this is the peak of our sorted array and hence our loop will stop over here, because now we'll just keep, now also as this is greater, we'll shift our right to this element and left will be equal to right, hence our binary search will stop. Thus we will return this left and that will be equal to the peak element. Now let's go into the code. Now why I'm just not doing right plus left by 2 is to prevent overflow. Suppose we have an array that is very large, and if we do simple left plus right by 2, it might overflow the integer range. So to prevent that, I am using right minus left. This makes sure that we don't overflow. Now if nums mid is less than nums mid plus 1, then I shift my left one step ahead of mid, else right is equal to mid. That's it. Return left. Let's try out this code. Okay, so the thing we are doing is we have initiated our binary search over here, and when we find mid for every left and right, whenever we see that if that mid is less than the next element, that means it is not the last element, so we'll shift our left to mid plus 1, and what this will do is it will increase our middle element. It will take our middle element to the other side of that array, and when we keep on doing this, we'll at certain point reach the peak element or the last element or maybe the first element, and when we do that, our left will be equal to right and we will return that. And as the outbounds of this array are always less than it, thus we will find the peak element. That's it for this question. So now if you have any doubts regarding this, you can put them in the comment section and I'll be happy to help you. So I'll see you guys in the next one.